Hello, everyone. Hope you are doing well. In this presentation, we are going to learn how to formulate the dual model in the linear programming with a simple example. Let's get started. In this presentation, we will first define the linear programming model for our model. Then we will move on to deriving its dual model step by step to understand its structure and properties. Let's examine the linear programming model that we will be working with. This model consists of three constraints, three variables, x1, x2, and x3, and two constraints, constraint number 1 and constraint number 2. One constraint is greater than or equal and one constraint is less than or equal, and all variables are non-negative. Understanding this model is essential before we begin constructing the dual formulation. Now, let's build the dual model by following a systematic approach. The original model is a maximization problem, so its dual will be minimization. So we have min, the abbreviation of minimization problem. Let's construct the first constraint in the dual model. The coefficient of x1 in the first constraint of the original model become the coefficient of the y1. So y1 is the dual of the first constraint and y2 is the dual of the second constraint. The coefficient of the x1 in the first constraint of the original model becomes the coefficient of the y1 in the first constraint of the dual model. Here, 1, 1. And the coefficient of the x1 in the second constraint, which is 1 of the original model, becomes the coefficient of the y2 in the first constraint of the dual model. The coefficient of the x1 in the objective function, which is 4, forms the right-hand side of the first constraint, so we have 4. Since x1 is non-negative, this constraint is written as here, the other color, better, red maybe, is greater than, so we have greater than or equal as well. Let's constrain the second constraint in the dual model. The coefficient of the x2 in the first constraint of the original model, that is 1, becomes the coefficient of the y1 in the second constraint. The coefficient of the x2 in the second constraint of the original model becomes the coefficient of the y2, so here 2. And the coefficient of the x2 in the objective function, which is 2, form the right-hand side of the second constraint. Since x2 is non-negative, here x2 is non-negative, so we have greater than or equal to in the second constraint. Constructing the third constraint in the dual model, the coefficient of x3 in the first constraint of the original model, which is 0, become the coefficient of the y1 in the third constraint, and the coefficient of x3 in the second constraint become the coefficient of y2 in the third constraint. And also the coefficient of the x3 in the objective function of the original model form the right-hand side of the third constraint of the dual model is 5. Since x3 is non-negative here, so we have greater than or equal. Additionally, the first constraint in the original model, the other column, is greater than or equal to, meaning that y1 would be non-positive. So we have non-positive. And for y2, second constraint is less than or equal, meaning that its dual variable, which is y2, must be non-negative. So y2 is non-negative. Thus, using this step, we successfully construct the dual model. Also, we need to write the objective function. Objective function, we write like this: 2 times y1 plus 20 times y2 would be objective function. Just multiply 2 by y1 plus 20 times y2. This is the dual model for the original model. In this example, we observe that if the constraint in the original model is greater than or equal, its corresponding dual variable is non-positive for the first year for y1. And if the constraint original model is less than or equal to its corresponding dual variable is non-negative for y2. Here, a question to consider: if a constraint in the original model is written as an equality, how should the corresponding dual would be defined? Share your idea in the comments of this video. Thank you so much for watching us. If you have any question or need assistance, feel free to contact us via email or through our website contact form. Do not forget to subscribe our YouTube channel to stay updated with new videos. Goodbye.